Hello everyone. This time we will be dealing with more problems about system of two nonlinear equations. So as I've said, there are three ways or methods to solve two nonlinear equations that could be either graphing, elimination, or substitution. So let's have problem 1, and the instruction says that we need to solve the system by elimination. So the given equations are 2x minus y is equal to 3, and then the other one is x squared minus y is equal to 2. This is our equation 1. This is our equation 2. So the whole point of using elimination, we're gonna cancel out or eliminate one of the variables when we try to add the two equations. So as of the moment, if we try to add equation 1 and equation 2, there's no way that one of the variables will be cancelled out. Because if you add 2x plus x squared, these are unlike terms, and negative y plus negative 1y would be negative 2y. So what would be our first step? So looking at our equation 1 and equation 2, y could have been cancelled out if they have opposite sides. So that's what we will deal first. We're gonna make sure that one of the y will become positive. So you choose either of the two. It's up to you which one. But in my end, I would like to change equation 2 and multiply it with negative 1. So it would turn out like negative 1 times the quantity of x squared minus y is equal to 2. So you just distribute. This will become negative x squared. And then this one, and then distribute the negative 1 to negative y turns out to be positive y, and then this will become equals negative 1 times 2 is negative 2. So there you go. Just copy, and by the way, this would be our equation 3 already, so that it's easier for us to communicate. So second, this is the best time that you will be adding equation 1 with equation 3. So take note, equation 3 is just the same as equation 2. It's just that we're trying to manipulate it. But still, remember, equation 3 is equation 2. So we're gonna add equation 1 with equation 3, and you're gonna align the like terms. So we have 2x minus y is equal to 3 plus, this is negative x squared. Do not align negative x squared with 2x because these are unlike terms. And then you put positive y below our negative y. So there you go. Negative y plus y will become 0. And this is negative x squared plus 2x is equal to positive 1. Okay. Now, what will you do afterwards? So, we're gonna find for x. You see, there's no more y and just x. So there's a way for us to solve this already. So similar last time, when we discussed this topic, we just have to make sure that it's written in general form. The right side should become a 0. So we need to add negative 1 in both sides. So 1 plus negative 1, 0. Then whatever you do on the left, do on the, whatever you do on the right, do on the left. So there you go. Next, the leading coefficient. When we say leading coefficient, it's variable with the highest degree. It's together with the variable with the highest degree in the equation. And you have x squared in here. And as of the moment, the leading coefficient is a negative 1. So we have to make it a positive 1. That would be possible by multiplying everything with a negative 1. So you'll do that. Multiply the left with negative 1, same on the right. This will become x squared minus 2x plus 1 is equal to 0. Then factor this out. The factored form, this is a quadratic trinomial. So we would have parentheses in here. Then x, because x times x is x squared. Then 1, that would just be negative 1 times negative 1 is equal to positive 1. And when you add them, it will become negative 2, which is our middle term. So this is the correct factored form. If you notice, the two binomials are exactly the same. So we can just write it as the square of x minus 1. So we will not be recalling or elaborate anymore. How did it happen? So what matters most now, there are two binomials and they're exactly the same. So you can just write them as the square of x minus 1. So you can just consider x minus 1 is equal to 0, just like last time. So one of the factors would be equal to 0. But since they're just the same, you can consider 1 only. So add 1 in both sides. So this will become 1. So x is equal to 1. We need to figure out what's the y. So we'll substitute x is equal to 1 to any of the equations that we have here. So perhaps I'll choose equation 1. So you have 2x minus y is equal to 3. So 2 times 1 minus y is equal to 3. So that would be 2. Add negative 2 in both sides. So negative y is equal to positive 1. And this is a negative y. Multiply both sides with negative 1. So this will become y is equal to negative 1. So here, our solution. So therefore, the solution is 1 and negative 1. Okay. As mentioned in the instruction, we need to graph the corresponding line and parabola to just verify whether our work is correct or not. So we will be using Desmos to check. Okay, so our first equation is 2x minus y is equal to 3. And that's a line as expected because the highest degree is a 1. And then the second is a parabola. And looking at the intersection between the parabola and the line, that is 1, negative 1. So our answer is correct. So this is an example of solving a system wherein there is one solution, meaning only one intersection. Let's now proceed to example 2. Still, we will be using elimination. So here, the given is negative x plus x squared plus y is equal to negative 7 and x squared plus y squared is equal to 9. So notice that our first equation is actually a parabola when you try to graph it. So you can recall our lesson last time regarding conic section and why is it that this is a parabola. And this one is a circle. As mentioned in the instruction, we will do elimination. So if you try to add them, notice that um, the x squared will be cancelled out already. So we are ready to go. So this is equation 1, equation 2, and we're now ready to add equation 1 plus equation 2 as our first step. Because again, the x will be cancelled out already once we add them. So just to show you, negative x squared plus y is equal to negative 7. You will add it with x squared. And then you put y squared perhaps here, but take note that they are not the same. So you cannot combine y and y squared. So you don't have the same exponent. But this one, they are like terms, so this will become 0. So x will be eliminated already, and what will be left is just y squared plus y is equal to 2. So same as example 1, we need to make the right side 0. So we're gonna add negative 2 in both sides. And then you just factor. Okay, so the correct factored form here, the first terms of our binomials would be y times y. So you have y and y in here. And for negative 2, you have positive 2 times negative 1, which will turn out to be negative 2, our third term. But when we add 2 and negative 1, that would result to a 1, which is our middle term. So this is correct, the 2 and negative 1. So you put or plug in plus 2 in here and then minus 1 in here. So let me just erase this. Okay, and we're gonna apply zero product property. So you have y plus 2 is equal to 0, and then the other one is y minus 1 is equal to 0. So y is equal to negative 2, and here y is equal to positive 1. So this is y sub 1, y sub 2, because there are two y values. So we're gonna find what is x if y is negative 2, and we're gonna find what is x if y is 1. So substitute y sub 1 to any of the equation. It's up to you which one would you prefer, but I'll have equation 1. So equation 1 is negative x squared plus y is equal to negative 7. And if y is negative 2, that means that I have to add a 2 in both sides to isolate negative x squared. So this would be negative 5. And then divide both sides by negative 1, or you can say multiply both sides with negative 1 or divide. It's up to you. Which one would you prefer? So x squared is equal to positive 5. Then don't forget that this is a square, not x is not isolated. So we need to get the square root of both sides. And when we try to get the square root of 5, that could be either a positive or a negative. So therefore, from that, there are two ordered pairs that we can come up with. So what are the ordered pairs? We have a positive of square root of 5, and of course the y would be negative 2. It can also be a negative of square root of 5, and then the y coordinate would be negative 2. And then we're not yet done, because you still have the other y value, which is 1. So we just have to substitute it similar to what we did here previously. So negative x squared plus 1 is equal to negative 7. We need to add a negative 1 in both sides. So that will turn out to be negative 8 in here. Because negative 7 plus negative 1 is negative 8. Then divide both sides by negative 1, or multiply both sides with negative 1. You will get an 8. And then you get the square root. So that would become positive or negative square root of 8. Why is it that this time we're considering a positive or a negative as a result? Unlike last time, the very last example from our synchronous, we remember that we only take the positive of it. Okay, just a reminder, we're talking about real situation in that case, which is about length, and length can only be positive. So it's okay to disregard the negative because there's no such thing as negative distance. In here, we're not talking about any application, so you really have to show up both positive of square root of 8 and negative of the square root of 8. Okay, so in other words, we can come up with a positive square root of 8 as our x-coordinate, and our y would be 1. The x-coordinate could be negative square root of 8, but the y would be 1. So notice that how many solutions do we have right now? There are actually 4 solutions. So we have first, second, the third, and the fourth. So why is it that there are 4 solutions this time? So let's try to verify if what we did is really correct in our Desmos application. So our first equation again is negative x squared plus y is equal to negative 7. And then the other one is x squared plus y squared is equal to 9. So here's the graph, and notice that there are 4 intersections. So here, 1, second, third, fourth. So there are four intersections between our circle and our parabola. And that's why our answer is here. Just to confirm as well whether it's really a square root of 8 and a square root of a 5. Because here in our Desmos, it's in decimal. So just to show to you, let's try to check. The square root of 5, okay, let's use our calculator here. In decimal, that is 2.36, which is here. And our square root of 8, that's 2 square root of 2 if you are asked to simplify the radical form. But since our Desmos shows the decimal form of the number, so if you change that in calculator, that would be 2.828, which is here. So our answer is correct. There are 4 solutions in our example 2. Okay, so let's proceed to example 3 now. So here, we're asked to solve the nonlinear equations with elimination as our method. Okay, now let's answer this. Okay, let me just copy it. We have x squared plus y is equal to 3, and negative x squared plus y is equal to 5. So if this would be our equation 1, this is our equation 2, we can already add equation 1 and equation 2 right away. Considering that x squared plus negative x squared is already 0. So x will be cancelled out already. So okay, if we add this will be cancelled out already. Y plus y is 2y, and then 3 plus 5 is an 8. Then we divide both sides with a 2. So y is equal to 4. And then, if we have the y already, we can figure out what is x when we substitute y is equal to 4 to either of our equations here. In my end, I want to use equation 1. So x squared plus y is equal to 3. We change y with a 4. And to isolate the x squared, we need to add a negative 4 in both sides. So just to show to you, we're gonna do this. Add negative 4 in here. Whatever you do on the left, do on the right to maintain the equality of our equation. So this will become negative 1. And if you notice, we need to get the square root of both sides to make this x squared an x. But when we do that, what will be inside our square root would be a negative 1. And square root of a negative number is imaginary. So what would be our conclusion if this one happens? Because you cannot figure out a square root of any negative number. 'Cause again, that's imaginary. So our conclusion here is there's no solution. When there is no solution, that means that there is no intersection between our two equations. Okay, so let's try to verify if that is true. We're gonna use Desmos again to easily graph our two equations. So we have x squared plus y is equal to 3. That's a parabola, and negative x squared plus y is equal to 5. If we try to zoom out this one, notice that the opening of our second equation is upward and the other one is downward. And they don't have any intersection at all. That's why our final answer is no solution. So example 3 is an example of a system with no solution. Example 2 is an example of a system with more than one solution. And example 1 is an example of a solution or a system with one solution. Okay, let's proceed to example 4. So, we will try to solve a system of nonlinear equations with elimination. So, we're still gonna use elimination for example 4. But example 4 is quite complicated compared to the others. So, the given is x squared over 4 plus y squared is equal to 1. And this is x squared minus y squared is equal to 1. This would be our equation 1. This would be our equation 2. Okay, now, looking at it, if you immediately add the two equations, that would be fine. Because y squared plus negative y squared is already 0. So, let's try to write that. X squared over 4 plus y squared is equal to 1 plus x squared minus y squared is equal to 1. So this will become 0. So you will have x squared over 4 plus x squared is equal to 2. Now, looking at our two terms in here on the left side of our equation, they have the same literal coefficient, which is x squared. And you can combine them because these are like terms. So when you combine like terms, remember 3x squared plus 2x squared, for example, you just have to copy the x squared and then 3 plus 2 is 5. We're gonna do the same thing here. So we're gonna copy x squared, the common literal coefficient, and then the numerical coefficient of our first term is actually 1/4. So use your calculator because you're allowed, so that would be fine. So 1/4 plus the numerical coefficient of our x squared in here in our second term is a 1 is 1. So plus 1. So you will get 5/4 x squared is equal to 2. Then to isolate the x squared, we need to multiply the reciprocal of our coefficient 5/4. So that would be 4/5. Whatever you do on the left, do on the right. So 4 will be cancelled out, same with the 5. So you'll have x squared is equal to 2 times 4, that's an 8. 8 over 5. Then you need to get the square root of 8 over 5. So I know that I hope you can still remember from grade 10 or grade 9. It's either of the two, depending on your school. But from my previous school, it's grade 9. When you get the square root of a fraction, you can just write it as a square root of 8 over square root of 5. But the problem is, you cannot consider a square root in the denominator. Okay? So, that means, um, perhaps you use your calculator. That's my best suggestion for you. If you can't remember what to do in here. So, the square root of 8 over 5, then you just put equals in here. That's already the simplest form. Those who can remember it without using calculator, then that's good. You will just rationalize. Multiply square root of 5 in the numerator and denominator, and you will get 2 square root of 10 over 5 still. So what will you do afterwards? Wait, I forgot. When you get the square root of a number that's positive or negative. So don't forget that. So we have two possible x's already. It's either positive 2 square root of 10 over 5 or a negative 2 square root of 10 over 5. So we just have to substitute that to any of our equation. So you choose which one. But in my end, I would like to use our second equation because there is a denominator for that will make things complicated. So x squared minus y squared is equal to 1. And then you have, perhaps here, it would be best if you just use square root of 8 over 10. So let me just explain to you why. But again, there's nothing wrong if you use this exactly. Okay, that would still be okay. So just to show you that they will be the same after this one. If I simplify this, if I get the square root of, or the square of a square root, always remember that that will become, sorry, this is a 5 based from our answer a while ago. Okay, when you get the square of a square root, that would just be 8 over 5 minus y squared is equal to 1. But even if you use this, okay, the simplest form of square root of 8 over 5, okay, let's try. Parenthesis, 2, let's put fraction first. Then 2 square root of 10, then denominator would be a 5. Then close parenthesis and then get the square. Okay, you will still get 8 over 5. Okay, so it's up to you what to do. Just be wise about it. Then, next would be isolate the y. So we need to add a negative 8 fifths in both sides. So 1 minus 8 fifths here. When we added a negative 8 fifths, it will become 0. So now, 1 minus 8 fifths, 1 minus 8 fifths is equal to negative 3 fifths. Then multiply negative 1 in both sides, you will get positive 3 fifths. And then you get the square root of both numbers. So y is equal to the square root of 3 fifths. That's positive or negative because that's square root. Then, if you simplify 3 fifths, square root of 3 fifths, that will become square root of 15 over 5. Okay. So that's it. So you'll just have to combine. Okay, choose the combination. Considering that there are two x's and there are two y's as well. So possible, the solutions are, first, the x could be positive, 2 square root of 10 over 5. And then the pair would be a positive square root of 15 over 5. It's also possible that the x would still be the same, but the y coordinate is the negative of it. The other possibility, the x would be a negative 2 tenths, 2 square root of 10 over 5, and then this would be the positive of square root of 15 over 5. Or this could be still negative 2 square root of 10 over 5, but instead of positive square root of 15 over 5, negative square root of 15 over 5. So how many solutions do we have? We have 1, 2, 3, 4. So let's check in our Desmos whether there are really 4 intersections. If there are 4 intersections, we're expecting 4 solutions as well. So this would be x squared. Okay, by the way, the first equation is an ellipse. I hope you can recognize the forms already. It's in standard form wherein you have x squared plus y squared. So this is a plus, and the right side is a 1. So this is an ellipse, as you can see. And then the other one is, of course, it's x. Both x and y are raised to a power of 2. We're expecting a circle for that. Not a circle. Sorry. It is a hyperbola. How did I know that it's hyperbola? Take note, the right side is a 1, and you have the square of x, the square of y, and the operation in the middle is a minus. So that's definitely a hyperbola. So let's try to add x squared, just to check if I'm correct, is equal to 1. There you go. So we have 4 intersection, first, second, third, fourth. So there are 4 intersections in here. Now, let's proceed to example number 5. Okay. Now, there are instances wherein elimination would not be beneficial when you try to find for its value of x and y. Okay, just like for example, this one in example 5. What if we use elimination as a method? So looking at it, x squared plus y squared is equal to 5. Then negative x plus y is equal to 1. When you add them, obviously they cannot be added because the degree here is a 2, degree here is a 1. So x cannot be cancelled out. Same with the y. If we try to manipulate one of our equations, let's say this is equation 1, equation 2, unlike our example 1, the concern is only the sign. So it's very easy to do something with that. But here, the concern is the exponent. If we wanted to cancel out the x squared, we need to get the square of the entire equation as well to make it equal or to maintain the equality of the equation. And that would be difficult. That would make things complicated. So here comes our second method, which is by substitution method. So we already discussed about substitution method last time. So I will not be explaining it again. But what you will do, consider one of the equations and then isolate the variable. Okay? So I'll choose equation 2. So if I choose equation 2, you have negative x plus y is equal to 1. Perhaps I'll isolate the y. So I have to add x in both sides. Okay, just to be sure that you really understand what I'm doing, I'll really show the details by adding x in here. So you will get y is equal to x plus 1. So y is already isolated. Therefore, we can have equation 3 in here for this one. So what we need to do next, substitute equation 3 to either of the equations. Not either, sorry. Equation 1. because equation 3 is from equation 2. So, equation 1 is x squared plus y squared is equal to 5. And y is x plus 1. So the square of x plus 1, I'm not sure if you can remember the special product for the square of a binomial. But if you don't, never mind. What matters most here, you know that the role of exponent is to multiply the base by itself. And the base of that exponent with a 2, it's actually x plus 1. In other words, you're multiplying x plus 1 by itself. And by itself twice. So use the FOIL method. First terms, x squared. Outer terms, x. Inner terms, x again, because 1 times x is x. Then last terms, 1 times 1 is 1. Then combine the like terms, x plus x, 2x. So there you go. That's the result. X squared plus 2x plus 1 is equal to 5. This x squared plus 2x plus 1 is coming from the square of x plus 1. The one that we did here. So I'll erase this. So that's not necessarily to be shown in your solution paper. Combine the like terms, x squared plus x squared is 2x squared. Okay. Now, the next thing that you need to do, you make the right side a 0. Okay. So you'll need to add negative 5. So 2x squared plus 2x minus 4 is equal to 0. Now, it would be convenient for us if the leading coefficient again is a 1 instead of a number which is higher or lower than a 1. So to make this to a 1, we need to divide this with a 2. Whatever you do here, do in every term including the right side. So that will become x squared. This will be cancelled out as well. 4 divided by 2 is a 2. 0 divided by 2 is 0. Then you just have to factor this out. So this is a quadratic trinomial. First term would be x. Because x times x squared. Then the last term, negative 2. That could be negative 2 times 1. But negative 2 times 1, yes, it's a negative 2. But negative 2 plus 1 is negative 1. And the middle term is a plus 1x. So plus 1, positive 1. So perhaps the issue is just the sign. So instead of 2 as negative, 1 will be the negative. 2 times negative 1 is negative 2. But 2 plus negative 1 is already 1. So there you go. Plug in positive 2, then minus 1. Then apply zero product property. X plus 2 is equal to 0. And the other one would be x minus 1 is equal to 0. Where x is negative 2, here x is equal to 1. And then you will be able to identify already what is the y by substituting x is equal to negative 2 to either of the equations that you have. Perhaps we will use equation equation 2. So negative x plus y is equal to 1. Negative times negative 2 is a 2. And then, oops. This will be 2. Then add negative 2 in both sides. So y is equal to negative 1. And the other one, substitute x is equal to 1 to equation, what did we use again? Equation 2. Equation 2. So negative 1 plus y is equal to 1. Add 1 in both sides, y is equal to 2. So therefore, we already have our values here. Okay, wait. Just to double check everything. Okay, yes, that's it. So our solutions are, we have negative 2, negative 1, and then the other one would be 1, 2. So just to double check or verify if our work is correct, let's go to our Desmos. So again, the given is x squared plus y squared is equal to 5. Then negative x plus y is equal to 1. So there are two intersections. This portion, which is negative 2, negative 1. And the other one is 1, 2. So our answers are correct. Okay, let's have example 6. So we're gonna use we're gonna use substitution to get the answer for example 6. So the equations are x squared plus y squared is equal to 5, and you have xy is equal to 2. So same process. This would be equation 1, this is equation 2, and then choose one of the equations. In my end, I will use equation 2, isolate one of the variables. I'll choose y. So we need to divide both sides by an x so that this will be cancelled out. And you'll have y is equal to 2 over x. Then you substitute. Um, then you substitute equation 3 to equation 1. The y is 2 over x, so you enclose it in a parenthesis. Now you're asked to get the square of 2 over x, so meaning 2 over x times 2 over x, numerator times numerator, denominator times denominator. So that would be 2 times 2, 4, x times x squared. So x squared plus 4 over x squared is equal to 5. And then, you have the denominator x squared in here. So it's very much better if we do not deal with denominators in equations. So to be able to cancel out the x squared in here, we need to multiply both sides with that itself. So multiply x squared on the left, same on the right. So when we distribute this, it will result to x to the power 4. And in here, the x squared will be cancelled out already. What will be left is just the 4. While this is 5x squared. Then you put them together on one side by adding negative 5x squared in both sides. So x to the power 4 minus 5x squared plus 4 is equal to 0. Now, you need to factor this. So how will we do that? Same. It's expected that there are two binomials as a result. So x to the power 4, that would be x squared times x squared perhaps. And then this is really more on trial and error, so you really have to be wise in finding the result. But for this, 4, 4 would have factor -4 times -1. Because -4 times -1 is +4. But when you add them, it will result to -5, which is our middle term. So just plug in -4 -1. Just like before, x squared minus 4 is equal to 0, or x squared minus 1 is equal to 0. So add the 4 in both sides. So this will become x squared is equal to 4. Get the square root. So positive or -2. Here, add 1 in both sides. Then get the square root. So positive or -1. So you have a lot of possible answers here. So we have to do it slowly. So we just have to substitute x is equal to +2 to our equation 2 perhaps. So that is just xy is equal to 2. So 2 times y is equal to 2. Divide both sides by 2. Y is equal to 1. If it is in -2, so -2 y is equal to 2. Divide both sides by -2. So y is equal to -1. If x is equal to 1, so that would just be y is equal to 2. And if x is equal to -1, okay, I hope you can still see it. X is equal to -1. So -1y is equal to 2. Or divide both sides by negative, y is equal to -2. So therefore, there are 4 solutions. So what are the solutions? That would just be +2, 1, -2, -1, 1, 2, and -1, -2. So there are 4 solutions. So let's verify using Desmos. So this is x squared plus y squared is equal to 5. Then xy is equal to 2. So there you go. Here are the intersections. 1, 2, 3, 4. So let's see if it matches. 2, 1 is here. -2, -1. 1, 2, -1, -2. So everything now is correct. Let's proceed to example 7. This is already a real-life application. We will talk about distance, speed, time problem. So a woman rows a boat upstream from one point on a river to another point 4 miles away in 1.5 hours. The return trip, traveling with the current, takes only 45 minutes. So how fast does she row relative to the water, and at what speed is the current flowing? So let us try to translate our situation into symbols. Okay. So here's our board again. So first of all, um, it's very important that you can picture out what is happening. We're talking about a river. So just remember, if there is a river, there is the flow of the river will go to one direction. So let's say the river goes to the left. So the situation says that there are 2 points where a woman go upstream, and the other situation, once he reaches the other other location, she went back. When we talk about upstream, meaning a person is going against the flow of the river or the current of the river. And then if in case we say downstream, that means that the boat follows the flow of the current. So that's why it will take a longer time if we have upstream, because you're against against the current, and it would be faster if you will follow the flow of the current. So it will help you to be faster. So there are two speeds given. There are two speeds that is missing in here. So let's try to translate them. So first of all, the rowing speed and the current speed. When we say rowing speed, this is how fast a woman can row the boat in the water. And when we talk about current speed, because of course there is contribution, how fast a woman can go from one point to another using the boat, depending on the speed of the water as well. So the current speed is how fast the water. So perhaps we can represent the rowing speed by x, and then the current speed as y. So there are two things that is happening here. There will be a speed upstream, considering both the rowing speed of the woman using the boat and the current speed of the water. Same with the return of the woman from its original location. So speed downstream. So the speed upstream would be x minus y. That would be the woman's speed already, considering her capability with the boat in paddling or rowing, and then the speed downstream, the speed of the woman would be x plus y. So why is it that it's a minus? Because at the first place, the woman or the boat will be slower because she is against the current. So the speed of the woman will depend um, on how fast the current is. And the speed downstream, since she is now going to follow the flow of the current, so it will help her to reach the original location. So x plus y. So I will just repeat it again just to be sure that you really understand it. So the speed upstream is the woman's speed already when she go from this point to the other. When she's against the current, so she will become slower because again she is against the current. So that would be x minus y. Then when we consider the speed of the woman downstream from this location to here, that would already be x plus y, because whatever is the rowing speed of the woman using the paddle, the river will help her to be faster. So that would be x plus y. So if this would be our representations, we will be able to come up with two equations. So our equation number one would be um, our equation when we try to consider upstream. So take note, remember this formula. Speed times the time is equal to the distance traveled. If you try to remember from last meeting, we have velocity is equal to distance over time. So just remember that velocity, we talk, that would be our speed now. And if we try to isolate the d, we need to multiply both sides with t. So it will turn out to be s times t. So that is still applicable until now. So speed times time is equal to distance. With that in mind, we already know that the distance from this point to here is 4 miles. So perhaps we can come up with our first equation when the woman goes to the other location, which is upstream. So that would be this, the distance would be 4 miles. And then the speed is represented now as x minus y. And then the time, it's 1.5 hours, but it would be best if we write that in improper fraction. So 1.5, 2 times 1 plus 3, 2 times 1 plus 1 is 3. So 3 halves. And then our other equation, our equation would be downstream. So the distance again is 4 miles. And then the speed when she for downstream is x plus y here. And then our time is in minutes, but we cannot just deal with units or situations with different units. So we need to convert the minutes to hours. So how do we convert minutes to hours? So in 45 minutes, remember that um, there are 60 minutes in 1 hour. So we put the 60 minutes in the denominator, 1 hour in the numerator. Then we cancel out the minutes. So you will get 45 over 60 hour. So just simplify 45 over 60. So that will become 3 over 40. Oh wait, it is not 600. So 45 over 60, that's 3/4. So you put 3/4 here. So those are the two equations that we have. Okay, but before anything else, we can simplify this by multiplying a 2 in both sides to cancel out the 2. So if we do that, multiplying 2 here on the left, it will become x minus y times the 3 equals 8. And then we can distribute the 3. So it will become 3x minus 3y is equal to 8. Here on our second equation, we multiply a 4 in both sides. So what will be left is x plus y times 3 is equal to 16. Then we distribute the 3. So 3x plus 3y is equal to 16. Okay. The question now is, what would be the best method to use here, elimination or substitution? So looking at our two equations, it's here. you'll notice that both of them has a 3y and they have opposite sides. So you can use elimination method to easily answer the problem. 3x minus 3y is equal to 8. Then 3x plus 3y is equal to 16. This will be cancelled out. X will be 0. 6x is equal to 16 plus 8 is 24. Then divide both sides by 6. You'll get 4. And then, finally, you just have to substitute x is equal to 4 to our first equation perhaps. So 3x minus 3y is equal to 8. 3 times 4 is 12. Then add negative 12 in both sides. You will get um, negative 4. Then divide both sides by negative 3. So y is equal to 4/3. So there you go. We already have the answer. Okay? So the question again is how fast does she row relative to the water and at what speed is the current flowing? So our x represents again the rowing speed and the current speed is for y. So the woman rows at 4 miles per hour. That's our x. This is in consideration of the rowing speed of the woman. And then the current flows at, take note, 4/3. Since it is a word problem, time is more probably meaningful if it's written in mixed number. And the mixed number for 4/3 is 1 and 1/3. So the current flows at 1 and 1/3 miles per hour. Let's proceed to our last problem related to mixture, to be specific in chemistry. So a vintner fortifies wine that contains 10% alcohol by adding a 70% solution to it. The resulting mixture has an alcoholic strength of 16% and fills 1,001 liter bottles. So how many liters of the wine and of the alcohol solution does the vintner use? So why is it so called as mixture? So I hope you can remember your lesson in grade 7 when you deal linear equation in one variable, because this is one of the type of problems that should be given to you, mixture. But the only difference is during that time the process would be quite complicated and very long, considering that in that grade level you only know how to solve an equation with one variable. But for now, as of this moment, you know already how to deal with x and y at the same time. In addition, you already know what to do if the exponent is higher than a 1 for the variables. So it would be faster. So try to think of it. There are, let's say, two bottles. Okay, two bottles in here. One is for wine, and the other is for the other one would be the alcohol solution. And it turns out that we try to combine them and result to a new wine with a new alcoholic solution. Okay? So that's how things work here. So what is asked from us is how many liters of wine and the alcoholic solution does the vintner use considering the result. So we'll represent the missing X as our amount of wine used. We still don't know. And the Y, which is our second container. So think of it as a container, the amount of alcohol solution used. By simply looking at the situation on top, we can already come up with an equation out from it and translate. So, first of all, um, it says that the wine contains 10% alcohol. So, in other words, okay. So, based from that statement, we will be able to get the amount of alcohol in wine by simply multiplying the percent of alcohol, which is 10%, in decimal, that would be 0.10, and we multiply it with the amount of wine you used. And then the amount of alcohol in our solution, think of it as the ones in our container, that would just be 70%. So 0.7 times y. So we will be able to come up with the first equation by simply thinking of it as whatever is the amount of the wine used added with the amount of alcohol. Since we combine them together, it will result to 1,000. Okay? 1,000 liters. Then, we can come up also with our equation 2 based from the alcohol, the amount of alcohol. So if we base it from that, it is expected that 0.10x plus 0.7y should result to a solution which is 0.16, because that's 16%. So that's our solution, resulting mixture, wherein the amount of resulting mixture would be 1,000 liters. So 0.16 times 1,000. So let's try to simplify equation 2 first before we proceed. You can consider it as 10 over 100. This one as, wait, you can just, let's try to multiply 1,000 with 16 first. So this would be 0.16 times 1,000, that would be 160. And then, so that the decimals here would become a whole number, we just have to make sure that the decimal point will move 1 point going to the right. So to do that, we need to multiply a 10 in both sides. So 0.10x plus 0.7y we multiply a 10. So distribute the 10. That will make it a 1 already. 1x. Then here, that will make it 7y. Then 160 times 10 is 1,600. So, that's our second equation. So, we already have x plus y is equal to 1,000 and x plus 7y is equal to 1,600. So, now it's up to you whether you will use substitution or elimination method. But in my end, I've noticed that I've noticed that they have the same variable in this portion. It's just that they have the same sign, positive. So perhaps my first action, so that I will be able to use elimination method, I have to multiply equation 2 with a negative 1. So if I do that, I multiply this with a negative 1, so this will result to negative x minus 7y is equal to negative 600. And that's a time that I can already apply elimination method. So x plus y is equal to 1,000 plus negative x minus 7y is equal to negative 1,600. So this will become 0. This is negative 6y is equal to 600. Negative 600 because the absolute value of 1,600 is greater than the 1,000 and the sign of negative 1,600 is a negative. So the result must be a negative 600. Then we divide both sides by negative 6. So y is equal to positive 100. So we already have the y, which is 100. That means that the amount of alcohol solution used is 100 liters. And then to figure out the amount of wine used, you just have to substitute y is equal to 100 to either of the solutions. So in my end, I want to use equation 1. Equation 1 is x plus y is equal to 1,000. So x plus 100. We just have to add negative 100 in both sides. So x is equal to 900. So there you go. That's the answer. We can conclude that the vintner uses 900 liters of wine and 100 liters of the alcohol solution.